This is the AP Calculus BC 2024 FRQs. Okay, so this is the first question. The temperature of coffee in a cup at time t minutes is modeled by a decreasing differentiable function, so decreasing function, where Ct is measured in degrees Celsius. For t equals 0 to t equals 12 minutes, selected values of Ct are given in the table shown here. Okay. So question number A, approximate C prime 5 using the average rate of change of C over the interval t equals 3 to t equals 7. Okay, so first C is modeling the temperature of coffee. Okay, we are being asked to find C prime 5 and we're being asked to approximate it using the average rate of change. So the average rate of change can be written as a difference quotient. So C prime 5 here should be approximated. So make sure to write that approximated out. And the difference quotient we're being asked to find over the interval t to 3 to t to 7 minutes. So we can write this out. 3 to 7 minutes. And C7, the temperature at 7 minutes is 69 degrees Celsius. And at t equals 3, it is 85. Okay, so we have to also show the work that leads to our answer, which is here, and include units of measure. So the units are degrees per minute because it is C prime and we're differentiating with respect to time. Okay, so it's this negative value, degrees Celsius per minute. Okay. Part B of the question is using a left Riemann sum. Okay, so with 3 subintervals by the data. So 0 to 3 is a subinterval, 3 to 7 is a subinterval, 7 to 12 is a subinterval. And use the data in the table to approximate the value of this integral. Interpret the meaning of 1 over 12 times the integral in the context of the problem. Okay, so first, a left Riemann sum is something like this. Okay, so this is a decreasing function C. We're plotting the temperature here. So at time 0, 3, 7, 12. The function is somewhat like this. And we're using left Riemann sum. So let's draw the left of these rectangles. Left rectangles. There are 3 rectangles and we need to add up all the areas. So at this point it is t equals 0. The temperature is 100 degrees Celsius. At t equals 3 it's 85, 69, and 55. So we can write the answer as, so we're being asked to approximate this first. Okay, so this is the integral from 0 to 12. Ct dt is also, you have to write out the approximating sign. Approximated equals to, the area of the first rectangle is 3 minus 0 times the height, which is, and first we have to write out times C0. So just write out the function of 0 first, and then write the value of the function. Okay, so here's plus 7 minus 3, and at this rectangle's area's height is at 85, so it's C3. And then third rectangle's height is C7. Alright, so the value of C0 is 100 C3 is 85. Okay, and we'll leave the answer like that. We just have to now interpret the meaning of 1 over 12 times this integral. So this should be the average value of CT from t equals 0 to t equals 12, because the integral of something divided by this 12 here, which is the minutes passed, should be the average value of CT when the distance passed. Okay, so 1 over 12 to 0 to 12 CT is the average temperature of the coffee, okay, in degrees Celsius, from t equals 0 to t equals 12 minutes. Okay, so this is the average temperature of the coffee. Okay, question C. For t equals 12 to t equals 20, the rate of change of the temperature of the coffee is modeled by this function, C prime t equals this thing, where C prime t is measured in degrees Celsius per minute. So this is the rate of the temperature. Find the temperature of the coffee at time t equals 20. Show the setup for calculations. Okay, so we're being asked to find what is C20. Okay, so to do these problems, you have to use the fundamental theorem of calculus. So something you might be given a value, and luckily we got t equals 12 here. So this function is defined for t equals 12 to t equals 20, and we have the temperature at t equals 20. So let's use this as the initial value. The fundamental theorem of calculus states that C20 minus C12 is equal to 12 to 20. Okay, this integral here, and C prime t, so C prime t dt. Okay. Now we are being asked to find C20. We have the value of C12, and we have the C prime t function here. So let's rearrange this. Plus C12. Okay, this function equals to negative 14670812. This is found using a calculator. So plus C12, which is given as 55. Okay, so make sure to write down C12 is equals to 55. Now C20 equals this value here, and we have to also write the units down. Okay, so the temperature of coffee at t equals 20 minutes is this amount of degrees Celsius, and you can solve that out too. Okay, and for the final question, number D, for the model defined in part C, which is C prime, it can be shown that C prime prime t is equals to this function. For t equals 12 minutes, t equals 20 minutes, determine whether the temperature of the coffee is changing at a decreasing rate or at an increasing rate. So remember that CT, so let's see, something, a function's rate, if a function's rate is, let's say, this prime t, this function is positive, then the function is increasing. And this function is C prime t, not CT, okay? So if the function's rate is negative, then C prime t is decreasing. Okay, and we're talking on that specific interval here. Okay, so we're being asked to find whether the temperature of the coffee is changing at a decreasing rate or at an increasing rate. So we're asking if the rate of the temperature, so it's C prime t, is increasing or decreasing. So we were given C prime t. C prime t is this function. And let's take a look at this function. So 24.55 is a positive number. E to the whatever power is also positive, because E is always positive. And t squared is also always positive. 100 minus t, so this C prime t is for t equals 12 to t equals 20. So if t is whatever number between 12 and 20, it is also larger than 0. So 100 minus t is also positive. So this C prime t is always positive for t equals 12 to t equals 20. So what does this mean? C prime t is always positive for this interval, then C prime t is always increasing on this interval. So we can write on the interval t equals 12, t equals 20, the temperature of the coffee is changing at an increasing rate. Okay, and question 1 is done.